Guys, Mr. Scrayback here again for our next lesson, Earth and Space Science. We have been talking a lot about stars recently. We started off talking about the life cycle of stars and how stars move from one phase of the protostar phase, where the star's just being created, and combining hydrogen into this fuel source that will become this process of nuclear fusion that burns over time, and then it moves through that main sequence, or maybe it goes straight to a red giant depending on how much hydrogen it has to start with to begin. But now today we're really going to kind of focus on the waves portion of that idea, because all this nuclear fusion that's being done inside the core of that star, just hydrogens slamming into hydrogens and fusing into helium, we looked at in the lab, creates a lot of energy. The more hydrogen you start with means the more energy producing reactions you're going to have over time. So all that energy is being released. And you might ask yourself, well, how does that energy look like, or what form does that energy take? And that's where we get into the second part of this next series of lessons, which is waves. Okay? Stars create energy, and that energy takes the form of waves, specifically electromagnetic waves. So you guys might remember this from fundamentals of physics. If you haven't had fundamentals of physics yet, you will kind of touch on this when you do take the course. But when we talk about the electromagnetic spectrum, what we're really discussing are types of energy that we can't necessarily see. Okay? Now, there is a thin band of energy that you actually can see, and that's light. So when you turn on a light bulb, that's visible light. That's electromagnetic radiation or electromagnetic energy that is traveling from the light bulb to your eyes in the form of waves. Okay, so this is how light travels. And we know light travels this way because it travels in a wave just like sound travels in a wave. And we know that because light has an echo. Except we don't call it an echo, we call it a reflection. So when you are looking at yourself in the mirror, you're seeing the echo of the light bouncing back at you. Okay? So light travels in waves. And that's not the only form of energy that travels in waves. We have longer wavelength light, which we can't see. Okay? Once you travel outside of this box, once your wavelength, the space between your tops of your waves gets longer, you're no longer in that visible spectrum. So these are things that are longer than that visible spectrum. So radio waves, microwaves, infrared waves, okay? We can't see those. And then we have things that are higher than the visible spectrum. So ultraviolet light, for instance, we can't see. You can feel it. You know, if you get a sunburn, that was UV rays touching your skin. And those short wavelengths have a lot of energy behind them, which is why they can damage your skin. And that's why things like X-rays and gamma rays can be harmful. X-rays aren't usually harmful. Like if you go in to get your, teeth X-rayed by your dentist, that's not harmful because we don't come into contact with those very often, but dental workers do. So that's why they leave the room whenever they do an X-ray, because otherwise they'd be getting bombarded by X-rays every single day, and that's not safe. But every once in a while, when you need it, if you break a bone or your tooth or whatever, then it's okay. Gamma rays, super dangerous, very short wavelengths, a lot of energy behind them, and those will harm you. I mean, that's the type of stuff that's really going to screw up your DNA, could really cause like radiation burns or even, forms of cancer and things like that. So this is a good little visual of the electromagnetic spectrum. This area, the visible light piece, is one that's really important when we talk about stars, because stars produce a lot of light. And as you read in the life cycle of a star lesson, you know that some stars have different colors. There's yellow stars, there's red stars, there's blue stars. Okay, there's a lot of different colors of stars out there. And you might be wondering, well, why? Why is one star yellow while one star's red? And we talked a little bit about that in the life cycle of a star lesson, but we're going to kind of build on that in today's lesson. So We're talking about stars and the waves that they create. And what I want you to do is I want you to go to this link on your handout today. So you're going to be filling in these questions. Okay. And this little web quest is called Catch the Waves. And sorry for the it's a little 90s to be honest with you, but the information in there is good. So you'll see these green words highlighted every once in a while where you can click on them and then it'll pop up with a definition there for you. Okay. And you can expand that if you need to. And this gives you the definition of the electromagnetic spectrum, which we've already talked about. The entire range of all the various kinds of radiation, light or the visible spectrum, comprises just one small segment of this much broader spectrum. Okay, so those of you who are already starting to copy and paste or just type exactly what was in there, I want you to stop. And I want you to put that definition in your own words, because you're not going to learn anything if you just press Control C, Control V. It's not going to do anything for you. You got to be trying to turn these definitions into your own words, okay? So these websites also have some fun little visuals, okay? So for instance, when we look at a star's light and we separate out that white light, we can see the various colors that are produced. So all light, all visible light, is broken down into these colors. Okay, it's that classic Roy G. Biv: red, orange, yellow, green, blue, indigo, violet. That all combines together to make white light. And when you put them through a prism, you can separate out the wavelengths. Okay. So as you're going through, you can see there's in the top corner, you see this next and back. Okay. So you can go ahead and click next. And then here brings up the next piece. So what do all waves have in common? All right. That is usually up here. So you make sure you're reading the website. All right. Like this one says waves. Click on that. And then you can read about waves and what they are and what they have in common to find your answer. So you really kind of have to click around and read the different information to get your answers. All right. And then you can kind of click on these to answer number 3, and so on and so forth. I'm not going to go through the whole thing with you guys. I just want to show you the website a little bit. Like here you can see watch this. Throws it in there, and you can see there's that little demonstration to describe what's going on. And all of this does connect. So you can see like water, guitar, sunlight. What do those all have in common? Well, we're talking about waves. So try and use those critical thinking skills, okay? And continue through. Make sure you're paying attention to what buttons you can press, what information's up here. Right, so a lot of these things, sometimes you might not think you can click on them, but you can. It's going to give you some more information, like I'm clicking through these to get some info. All right. And then these are really good too. So as you continue to move on, you're just going to kind of go through and do each of these. All right. You can see that there's some questions down here that you're going to be recording in here. So this should really walk you through what you're going to be doing on each of those pages as you record your answers. And if you have any questions, like always, make sure you email me. If you're working on this week, come see me during office hours on Tuesday between 11 a.m. and 1 p.m. If there's any changes, I'll post those onto Google Classroom. I really hope you guys are staying healthy. Hope you're trying to help each other stay happy as best you can. It's nice that the warmer weather seems to be here to stay. At least I'm crossing my fingers. You know, it is Maine. But I miss you guys. I hope to see you sooner rather than later. Looking forward to trying to get back to a new sense of normal in the fall. So I hope to see you guys soon. Have a good one. Bye-bye.